Hello and welcome back to another Orange Coast College Mathematics video. This video is a continuation of our topic on polar graphs, in which we take everything that we've learned so far and try to graph various functions. So let's move on to number 2. We have r is equal to 3 cosine of 2 theta. So let's go ahead and try to identify what this is. Well, 3 cosine of 2 theta, I'm not adding anything to it, so it's not going to be a limacon. Now, we don't have an r squared here, so it's not going to be a lemniscate. It's not going to be a circle because it has this 2 in here. So, the last one that we have is a rose curve. So we know that this is going to be a rose curve, and we know since it's being multiplied by 3 that the petals are going to have a length of 3. Now, luckily, this is cosine, so we don't have to figure out where the petal starts. We know that it's going to start on the horizontal axis. Now, what is our n value? Our n value is 2, which is an even number. So we're going to have to double that value, and that's going to be how many petals we have. So we have a rose curve with 4 petals. So let's go ahead and try to figure out what symmetries we have. Now, to test for our symmetry about the polar axis, we need to replace theta with negative theta. So let's plug it in. So we have f of negative theta is equal to 3 cosine of 2 times negative theta. Well, I can rewrite that as 3 cosine of negative 2 theta. Now I'm going to use the identity of cosine of negative theta is equal to cosine of positive theta. So we end up getting that this is equal to 3 cosine of positive 2 theta. That's what we started with. That is our original function. So this is equal to f of positive theta. So we know that we have polar axis symmetry, which hopefully makes sense. If you go back to the picture of what a rose curve looks like with cosine, it should have polar axis symmetry. It should reflect over the horizontal axis. Now let's check the symmetry about the pole. For this one, we have to replace theta with pi plus theta. So we have f of pi plus theta is going to be equal to 3 cosine of 2 times pi plus theta. Now, rewriting that out and distributing, we're going to have 3 cosine of 2 pi plus 2 theta. Now, there's actually 2 ways that we can do this. I'll show you the identity you could use, but we're not actually going to do that. We'll do an easier way instead. But let's look at the identity that we could use here. We could use the identity cosine of a plus b is equal to cosine of a times cosine of b minus sine of a times sine of b. Now, we could use this identity and we would end up getting the correct answer. But instead of doing it that way, let's actually take a look at our angle. 2 pi plus 2 theta. In particular, let's focus on the 2 pi. What is an angle of 2 pi? An angle of 2 pi is starting at 0, going around a complete circle and ending up back there. So really, it's just saying that I'm going to take whatever angle I have, being 2 theta, and I'm going to go around a complete circle and end up at that same angle. So adding 2 pi to the angle doesn't actually do anything. So really, this is going to be equal to 3 cosine of 2 theta, which is our original function. So this is equal to f of theta. So since f of pi plus theta is equal to f of theta, we have symmetry about the pole. And again, if you go back up to the picture, that should hopefully make sense. Now let's check the symmetry about the vertical axis, our pi over 2 axis. For this one, we need to replace theta with pi minus theta. So we have f of pi minus theta. That's going to be equal to 3 cosine of 2 times pi minus theta. We can distribute that out, and we'll have 3 cosine of 2 pi minus 2 theta. Now, we could use this identity, which is cosine of a minus b is equal to cosine of a times cosine of b plus sine of a times sine of b. But we can use the same logic that we just used to get around having to use this. This 2 pi minus 2 theta, I can rewrite this as negative 2 theta plus 2 pi. So just like the last one, I'm going to be dealing with an angle, and then I'm going to add 2 pi to it. So it's just going to be this angle, and I'm going to go around in a full circle and then come back to where I started with. So this positive 2 pi doesn't actually do anything. So we're going to be left with 3 cosine of negative 2 theta. Now, we used the identity before, but let me rewrite it. Cosine of negative theta is actually equal to cosine of positive theta. So, writing this up here, we're going to have 3 cosine of 2 theta, which is our original function. This is f of theta. So, f of pi minus theta is equal to f of theta. We have symmetry about the vertical axis. So we actually have all 3 types of symmetry with this. Since we have all 3 types of symmetry, we actually have to do a lot less work. Now, just like before, let's figure out which angles we want to solve for. So I'm going to come down here. So I'm thinking, whatever I take in here, I'm going to flip it over the vertical axis. I also know that I'm going to flip it over the horizontal axis as well. And I know I'm going to flip it over the pole, which is kind of like the origin. So you'd flip it over the horizontal and the vertical, and you'd end up with here. So if I just cover these angles in this kind of first quadrant, I know when I flip it over the vertical, I'm going to get these angles over here. And when I flip it over the horizontal, I'm going to get these ones right here. Then when I flip it over the pole, I'm going to get these ones over here. So all I have to do is get these angles. So let's go ahead and solve for those. So we have 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. So let's start plugging them in. So we have 3 times cosine of 2 times 0, which is just going to be 0. So cosine of 0 is equal to 1. So we have 3 times 1, which is going to be equal to 3. So we have the point 3, 0. At 30 degrees, we're going to have 3 cosine of 2 times 30 degrees. So that's going to be 60. Cosine of 60 degrees is 1/2. So we have 3 times 1/2, and that's going to be 1.5. So we have 1.5 at the angle 30 degrees. Now that may seem a little confusing, right? Because when we multiply it by 2, we get 60 degrees. However, the line that we're moving along is the 30-degree line. What we do inside of our function is not going to affect that angle that we're kind of moving along. So just be careful about that. Now, at 45 degrees, we have 3 times cosine of 2 times 45 degrees, which is going to be 90 degrees. Cosine of 90 degrees is actually 0. So we have 3 times 0, and so we get a value of 0. So we get the point 0 at 45 degrees. Now, at 60 degrees, we have 3 cosine of 2 times 60 is 120, so 120 degrees. Now cosine of 120 degrees is negative 1/2. So we have 3 times negative 1/2, and so we have negative 1.5. So we have a point of negative 1.5 at an angle of 60 degrees. And finally, at 90 degrees, we have 3 cosine of 2 times 90, which is 180. So cosine of 180 degrees is going to be negative 1. So we have 3 times negative 1, and that's going to be equal to negative 3. So we have negative 3 at 90 degrees. So let's go ahead and plot these points. So at an angle of 0, we had a value of 3. So we'll go out to the third circle. Then at 30 degrees, we had a value of 1.5. And then at 45 degrees, we had a value of 0. So we're at the pole. Then at 60 degrees, we had a value of negative 1.5. Now remember, 60 degrees is along this line. Now going in this direction would be positive. So if we have a negative 1.5, we're going to be going along the other direction. So negative 1.5 is going to land us over here. Now at 90 degrees, we have a value of negative 3. So 90 degrees, this is the positive direction. The negative direction is downward. So we get a point over here. Now connecting this, we have. Now this may look a little strange because you would expect that since we did only these angles in kind of this first quadrant, that all of our points should be somewhere in there. But because we have those negative values, we ended up getting points over here. However, we still only dealt with these angles. So when we do our symmetries, we're going to get the points associated with these angles, and then these angles. So this is kind of a trust the process kind of a thing. So let's go up and look at our symmetries. Now, when dealing with our vertical axis symmetry, we had to do pi minus theta. Now, because we're dealing with degrees, let's note that pi is equal to 180 degrees. So all we have to do is take our same point that we found and do pi minus that angle. So our r values are going to stay the same. So I'm just going to go ahead and write them all in right now. So we have 3, we have 1.5, we have 0, we have negative 1.5, and we have negative 3. The only thing that's going to change is our angles. So let's do pi minus these angles. Pi minus 0 is just going to be pi, so it's 180 degrees. 180 degrees minus 30 degrees is 150 degrees. 180 degrees minus 45 degrees is going to be 135 degrees. 180 degrees minus 60 degrees is going to be 120 degrees. And 180 degrees minus 90 degrees is going to be 90. So let's go ahead and take these and plot these points now. So at an angle of 180 degrees, we have a value of 3. So we'll plot the point right there. Then at 150 degrees, we have 1.5. So right over here. Now at 135 degrees, we're actually at a value of 0. So we're back on the pole. At 120 degrees, we have a value of negative 1.5. So we'll be about right here. And then at 90 degrees, we have a value of negative 3. So we'll be right over here. Connecting all this, we're going to have and so now we've got that symmetry dealt with. So now let's go back to our other symmetries. When dealing with symmetry about the pole, we replaced theta with pi plus theta. So pi plus theta. So we're going to do the same exact thing we just did for our vertical axis, but instead of pi minus theta, we're going to do pi plus theta. So I'm going to go ahead and write our r values in because those are not going to change. So we have 3, and then 1.5, 0, negative 1.5, and negative 3. So again, pi is 180 degrees, so pi plus theta, we're going to have 180 degrees plus 0 is going to be 180. And then we have 180 degrees plus 30. That's going to be 210 degrees. Then 180 plus 45, that's going to be 225 degrees. 180 degrees plus 60 degrees is going to be 240 degrees. And finally, 180 degrees plus 90 is going to be 270. Let's go ahead and plot these points now. So at an angle of 180 degrees, we have a value of 3. Then at an angle of 210 degrees, we have a value of 1.5. So it'll be around there. Then at 225, we go to the pole. At 240 degrees, we have a value of negative 1.5. So it'll be around here. And then finally, at an angle of 270 degrees, we have a value of negative 3. So that'll be over here. Connecting all this, we'll have... Now this is starting to look really good, and it's starting to really look like this rose curve that we were expecting. We're almost done though, so let's look at our last symmetry. When dealing with polar axis symmetry, or our horizontal axis symmetry, we replaced theta with negative theta. So, just like the other ones, I'm going to write our r values in. So we have 3, 1.5, 0, negative 1.5, and negative 3. And now we'll do negative theta. So negative 0 is going to be 0. Then we'll have negative 30 degrees. Then negative 45. Negative 60. And then finally negative 90. Now let's go ahead and plot the rest of our points. So at an angle of 0, we had a value of 3. At negative 30 degrees, we have a value of 1.5. Remember, negative angle is going in the clockwise direction, so our point is going to be about right there. Then at negative 45 degrees, we're going to be back at the pole. At negative 60 degrees, we're going to have a value of negative 1.5, so it'll be around there. And then finally, at negative 90 degrees, we have a value of negative 3. So it comes all the way up there. Connecting these, we get... And that is our final sketch. Now notice this is exactly what we were expecting. We were expecting to have a rose curve with 4 petals, and because it was cosine that we were dealing with, our first petal started on the horizontal axis. Now personally, I think this looks pretty cool. So hopefully this made some sense. I'm sorry this was such a long one, but these problems can be kind of tedious sometimes. You'll get a lot faster at them as you do them, I promise. Anyways, that's going to do it for this video, and I hope to see you in the next one.